Everybody, and welcome back. In lieu of the homework, what I planned on doing for the hypothesis testing chapter was a group work exercise. In the group work exercise, everyone would have brought their laptop, tablet, whatever you may have, and then gone through the series of 5 questions together as a group. These questions can be a little bit challenging, so rather than jumping directly to the homework, and since we don't have the ability to do group work, what I'm going to do is walk you through the 5 questions that we would have been discussing in our group work. What that means is that for the hypothesis testing, there will not be a homework section, but there will be a quiz section at the end on WebAssign. So we have 5 questions, and the direction for each question is simple. Determine the null and alternative hypotheses, use stack key to find the p-value, and then make a determination on whether we are rejecting or failing to reject the null hypothesis. So let's start with our first question. In a recent survey found that 68.6% of the population own their own home. In a random sample of 150 heads of household, 92 responded that they did in fact own their own home. At a level of significance of 0.01, remember that's our maximum type 1 error, does this suggest a difference from the national proportion? So our question is it different? I'm not saying that it's higher, I'm not saying that it's lower, I'm asking if it's different, so this would be our two-tailed, right? So this is going to be a not equal to statement. Remember that the null hypothesis is always a statement of equality. We're dealing with a population proportion. My variable is p. So p would equal that 0.686. For the alternative hypothesis, if I'm saying that they're merely different, I'm saying that the value does not equal 0.686. So let's do that. P does not equal, we have our does not equal symbol up here, 0.686. I have one too many zeros here. Let's change that. Insert our equation, P equals 0.686. So we have our null and our alternative hypothesis. We now know that this is a two-tailed test. With this being two-tailed, we need to now go into stack key to determine the p-value. We'll compare p directly to alpha. So into stack key. We're going to start with a fresh page. We're doing a randomization test and we're dealing with a population proportion. Randomization test for a single proportion. The first thing we have to do is insert our data. Our data told us that 92 out of 150 own their own home. So my data here will be 92 out of 150. Next, I need to edit the null hypothesis. This is always set at 0.5. Our null hypothesis was 686 thousandths. Now that the null hypothesis has been entered and my data has been entered, we can now finally generate our samples. We're going to generate that Monte Carlo, our 10,000 samples. If you made 11,000, if you made 9,000, it's not going to dramatically change our p-value, but I'm always going to try to make 10,000. What did we say? Was this left-tailed, right-tailed? This was two-tailed. With our two-tailed test, we need to make sure that our cutoff matches our sample proportion. The sample proportion's up top. 613 thousandths. Well, my cutoff is already at 613 thousandths. That's not always going to be the case. That's just a nice coincidence in this particular problem. So what I'm going to do is I'm actually going to copy this data and we're going to put it directly into our Word document. So we'll select the document, edit, select all, edit, copy, and we're going to put it directly into our Word document that you'll have to use as a guide. So what is my p-value? Well, the p-value is the size of the tails, and with a two-tailed test, I have two tails. So the p-value, insert our equation, the p-value will equal the 25 thousandths by 2, or 5 hundredths. The probability of finding a value that extreme or more extreme is 5%. That's what we're saying here with our p-value. To complete the hypothesis test, what we want to do now is compare p to alpha. My alpha value, that maximum type 1 error, was 1% or 0.01. So what will we say? P is greater than alpha. And because P is greater than alpha, we fail to reject. We fail to reject specifically the null hypothesis. There is not enough evidence to confirm that the population proportion of homeowners is different than our null hypothesis, 68.6%. Confirm that the population proportion is different than that 68.6%. That's all there is to it with these questions. Once we find the p-value using StatKey, this is what we're avoiding what a traditional Stat 1 class would have had to find by hand. Our decision's made for us. We just compare p directly to alpha. Let's look at our second example. Researchers suspect that 18% of all high school students smoke at least one pack of cigarettes a day. After an anti-smoking campaign, researchers believe that this has decreased. We have a sample of 300 students, and 50 of them smoke at least one pack a day. If I have a level of significance of 0.05, let's test the claim. Well, as always, the first thing we have to do is establish the null and the alternative hypothesis. The null hypothesis here will be that p is equal to that 18% or 0.08. Again, p because it's still a proportion. The alternative, what did we claim? We were claiming that this is decreasing. So the alternative should be that it's less than 18%. Now that I have my hypotheses, and we know that this is left-tailed, the inequality is pointing to the left, now we go into StatKey. So let's start with a new screen on StatKey. Again, we're dealing with a single proportion. But now my data is that 50 out of 300 were smoking from my sample. My null hypothesis was 18%. And again, the null is always a statement of equality. We believe that this is decreased, that this will be left-tailed. Let's generate our samples. And 10,000. Left-tailed, we need to make sure that our cutoff matches our sample proportion. Our sample proportion was 167 thousandths, so let's make sure that matches up. Now the p-value is just the area to the left. What is my p-value? 301 thousandths. What I'm saying is that if my null hypothesis is in fact 18%, I would expect approximately 30% of my sample values to be at my sampler proportion or lower. That's not a un, that's not a surprising result. That's not an unlikely result. So let's copy our data in. If you have a Mac, all I'm using is Command Shift 4. I'm sure there's a similar way to do this on a PC. I'm going to copy my data. Copy. And we're just going to paste it in. Now that I have this value pasted in, I compare P to alpha. Alpha, remember, was our 5%. Our p-value was 30.1%. P was clearly greater than alpha here. And where's my alpha variable? There we go. P is greater than alpha. And if P is greater than alpha, we fail to reject the null hypothesis. There's not enough evidence to support that the anti-smoking campaign actually caused a decrease in the number of smokers. That's all we have to do in order to summarize. So 2 questions down, we have 3 to go. So far, both of my results were failing to reject. Let's look at our third question. An attorney claims that more than 25% of lawyers advertise. If we took a sample of 200 lawyers and found that 63 of them had some form of advertisement, at a level of significance of 0.05, is there enough evidence to support this attorney's claim? Let's see. Still dealing with a population proportion, P would equal 0.25 for the null. What would the alternative be? The lawyer's claiming that it's more than 25%. So the alternative is greater than. This would be right-tailed. Let's go into stack key. In stack key, let's clear out of our old pictures first. Now in stack key, still dealing with a single proportion, our data showed that 63 out of 200 lawyers were advertising. Our null hypothesis was that 25% were. And we generate our samples. I have my 10,000, I have my Monte Carlo. I select right-tailed, this is greater than, and then I want to make sure that my sample proportion matches up with my cutoff, and it does. What is the p-value? What is the area to the right? 25 thousandths. So let's select our data. Once again, I'm going to copy this data into our Word document that I will post onto Blackboard. We paste it in. Now, as you do these randomization tests, the samples that I'm randomly generating are not necessarily the same as the samples that you randomly generated. So your p-value may be slightly different. That's okay. It's not going to be off by enough to change whether we're rejecting or not. Okay. So what do? I compare P to alpha. We said that P was 25 thousandths, which means that P is less than alpha finally. Let me go back up and select my alpha value. P is less than alpha. If p is less than alpha, we actually now finally have enough evidence to reject the null hypothesis. What we're saying is, what is the probability that if my null hypothesis is true, that we had a sample that was this extreme or more extreme? The probability that that occurred was only 2.5%, so that's an unlikely result. So what we're doing is rejecting the null hypothesis. There is enough evidence to support the claim that more than 25% of lawyers advertise. That's all. We're using P to make our decision. So we had 3 examples for population proportion: right-tailed, left-tailed, two-tailed. We had examples of rejecting, we had examples of failing to reject. In our remaining 2 examples, we're now going to look at the mean value. How we enter the information into StatKey to find the p-value is the only thing that changes. We're still comparing p to alpha. Let's look at question 4. A researcher estimates that the average height of buildings 30 or more stories in a large city is at least 700 feet. If we took a random sample of 10 buildings, shown below, test that claim. This is where we have to be careful. First of all, I'm dealing now with the mean value. The population mean is mu. So let's go to our Greek alphabet here and select mu. Being careful, the null hypothesis is always a statement of equality. So this could be a strictly equal to, or a greater than or equal to, or less than or equal to. Let's read this again one more time. The researcher estimates that the average height of buildings 30 or more stories is at least 700 feet. At least means 700 or more. So the equals is with 700 feet. What would be the alternative to at least 700 feet? The alternative to 700 or more would have to be less than 700. This is a left-tailed test. Be careful when you see statements like at least or at most. So this is left-tailed. Now that we see that this is left-tailed, we have to enter the data directly into StatKey. To make it a little bit easier, I have these values typed into Excel. We're just going to copy and paste. So question 4 data. We'll copy the data, and now let's go into StatKey. In StatKey, we're now doing a randomization test, not for a proportion, but for the mean value. When I edit my data, I'm going to make sure that I don't have a header row selected unless I actually have one. We said that there was 10 data points, and I see here that I have 10. My null hypothesis was that the mean was equal to 700. Let's change this value to 700, and now we can generate our samples. We have our Monte Carlo. We have a 10,000. We said that this was left-tailed. Again, left-tailed because this was less than for our alternative hypothesis. Now let's make sure that the cutoff matches the original sample value. My original sample mean had a height of only 606.5 feet. Look how small that p-value is. If the true average height of buildings 30 or more stories was 700 feet, the probability that we randomly selected the group that we had and we got a value of 606.5 feet or smaller from my sample, this p-value is my probability. Very small, very unlikely. Let's copy our data in. Select all, edit copy. So now that we have the data in, we can clearly see that the p-value is very small. That p-value is going to be less than alpha. And if p is, because our alpha value, our level of significance was 0.05, we can use the alpha symbol, that's fine. And as p is less than alpha, we have enough evidence to reject the null hypothesis. By rejecting the null, I'm saying there is enough evidence to support that the average height of buildings 30 or more stories is less than 700 feet. So again, there is enough evidence to support that the average height is actually less. And the reason is because the p-value is so small compared to alpha, we could actually reject the null hypothesis. Last example. The average monthly cell phone bill was reported to be only $50.07. You can tell this is an old question. I'd love for a cell phone bill to be $50 a month. A random sample of a large cell phone company found that the following charges below were their monthly cell phone bills. At a level of significance of 0.05, has the average cell phone bill increased? So we're dealing with average again, so we're dealing with mu. The null is always the statement of equality, so I'm saying that this was equal to $50.07. What is my question here, my alternative? I'm asking you, has the bill increased? So I'm asking you if mu is now greater than $50.07. This is right-tailed. This is a greater than statement. Once again, I have the data selected in Excel. This way we didn't have to try to copy and paste this over. So I'm going to go back to the beginning of StatKey and go to a single mean randomization test and insert my data. Once again, no header row. Our null hypothesis was $50.07. Right. Now we can generate our samples. Our alternative hypothesis is that the bill is increased, which makes this right-tailed. And now we want to make sure that our cutoff matches our sample data. So our cutoff here should be $56 and just over 11 cents. By doing this, I'm now able to find my p-value. P here is 38/10,000ths, which will be less than alpha. So we are going to reject the null hypothesis again. So let's quickly copy and paste this data over. Alpha again was 0.05. My p-value was 38/10,000ths. So p is clearly less than alpha. And as p is less than alpha, we will reject the null hypothesis. The probability that if the true average price was $50.07, the probability that my sample data, my sample average of $56 and just over 11 cents, having an average price of that or higher, it's about 0.4% chance. Very unlikely. So we're rejecting the null hypothesis. There is enough evidence to support the claim that the average cell phone monthly plan, or the average cell phone plan, has increased. This is what I'm looking for when you go through these questions. You have to be able to use stat key. There are other techniques in which you can determine hypothesis testing. Those aren't the techniques that we are using in this class. So if you use outside resources in other classes, that's typically fine. For this section and for our bootstrap confidence interval section, you're not able to do that. So if you have questions, reach out to me. I'm going to post this online, and I'm also going to post the Word document online so that you're able to access that as well. Again, this group exercise was in lieu of the homework. Make sure that you can get to the same results by using StatKey so that when I give you the quiz, you know exactly what you're doing. Good luck, everyone. Stay home and stay safe.